Hi everyone, welcome to this new lecture of hydraulic machines. In this lecture, we'll solve a problem on models of centrifugal pump. So in our last lecture, we have discussed about the models of centrifugal pump, and also I told you that why this model is required on behalf of a prototype, and what are the conditions need to be satisfied for the models and prototypes. So all the things we have discussed in our last video lecture. So based on that concept, we'll solve this problem. So the question is given a single stage centrifugal pump. So the centrifugal pump is given single stage. If it is a multi-stage, it will be different. So single stage given with an impeller diameter is given 30 centimeter, which rotates at 2000 rpm and lifts 3 meter cube of water per second to a height of 30 meter with an efficiency of 75%. Find the number of stages and the diameter of each impeller of similar multi-stage pump to lift 5 meter cube of water per second to a height of 200 meters when it is rotating with 1500 rpm. That means it is given one single stage, another one is multi-stage given. Okay, multi-stage pumps, single stage pump and a multi-stage centrifugal pump, and for each it is given data are given. Okay, so we need to similarize like a single stage pump and the multi-stage similar pump. Okay, and we need to find out the number of stages and diameter of each impeller. Okay, so we need to find out. So first of all, let's try to identify the data given from this question. Then we'll try to solve it how it is. Data given. So here if you see in the first one, let me write this is the single stage centrifugal pump. The first category is single stage centrifugal pump. Okay, so in this if you see the diameter of this impeller is given, so we can write this is suppose diameter d1 is nothing but 30 centimeter given, and here we can write this is in terms of meter. Let's convert this unit into meter, and speed of that impeller is given. So this one I can write n1. So n1 is given, speed is 2000 rpm. Okay, and next it lifts 3 meter cube of water per second. So that means the discharge is given. So we can write this is q1. Q1 is given 3 meter cube of per second, and to a height of 30 meter. So height of 30 meter in the sense the total head is 30 meter here. So the manometric head we can write 30 meter, HM equal to 30 meter, and with an efficiency of 75%. So here the efficiency is actually nothing but the manometric efficiency. So we can write the manometric efficiency is 75%, and this one we can write this is 0.75. So these are the data are given for the single stage centrifugal pump. Now the next data is given for the multi-stage similar pump. So next data we'll write for the multi-stage, okay, multi-stage similar pump which is given. Let's write the same thing, multi-stage similar pump. So from here we need to identify which stage and what are the diameters. So these two things are. Now in the second part, if you see, find the number of stages, diameter, similar multi-stage pump which lifts Q. So here is Q is given, Q2 is given, this is 5 meter cube per second, and the second part is given which a height of 200 meters. That means the manometric height HM2, this is 200 meter, and when it is rotating with 1500 rpm. So here rpm n2 is given, 1500 rpm. So these are the data are given in this. Now if you see the diameter of each impeller we need to find out, and the number of stages we need to find out. Okay, now to find out these things we need to follow like our previous formula what we have used. If you see the previous one, so diameter of each impeller we can consider that is d2. this one we complete, this one we can consider diameter of each impeller, we can consider D2. So to find out this number of stages and diameter of each one, so each impeller of similar multi-stage pump, not the first one, second one. So first of all, we need to go for the specific speed, because from the specific speed we can find out the terminology. If you see the formula of specific speed, there we have the formula of like hm2 I can say. Okay, so specific speed formula is we know that this is n root over of q divided by this is hm to the power 3 by 4. Okay, and now as per this the models of centrifugal pump, we know that we can write this is for the model equal to this is for the prototype. So same thing I'll write for this is 1, this is for the first one, and another equation for the second one. So I can write here this is n2 root over of q2, and this is hm2 to the power 3 by 4. Now here if you see, we have the value of q is there, n is there. Now you see q1, n1, like n1, q1 both are given. Here also if you see q2 is given, n2 also given. So what is the unknown here? hm1 also given here. Now hm2, yeah, hm2 is given, but here hm2 is not 200 actually. Here if you see the total height, the water per second to a height of 200 meter when it is rotating this one. So this is actually the total height, not the hm2. This is actually the total height, 200 meter. Now we need to find out the height per stage. For this stage, what is the height? That means hm2 need to be actually calculated. Okay. Now hm2 is not given, everything is known to us except the hm2. So we can find out the value of, like, let me write here, hm2 I'll keep it one side. So hm2 to the power 3 by 4 is equal to, we can write n2. What is the value of n2 here? 2000, sorry, 1500. So we can write this is 1500 into this is root over of q2. q2 is nothing but 5, and this one will go to multiply here. So I can write this is hm1. hm1 how much? 30. So 30 to the power 3 by 4, and this is divided by n1. n1 equal to 2000. n1 equal to 2000 into root over of this is q1, this is 3, and from here we can find out the value of hm2 to the power 3 by 4. Now let me write this is hm to the power 3 by 4, and this one we need to solve it. Okay, so let's write down root over of 5. First one we'll go for root over of 5, 2.23. so here I can write this is 1500 into this is 2.2, some value is there 236, so I can write this is 24, and 30 to the power 3 by 4, let's find out. Yeah, 30, this is, we can write to the power function. Here I can write bracket start 3 by 4 bracket close. Okay, so this will get 12.818. so this is 12.818, and here it is different will be there. Let's see. Now this multiply 1500 multiply 2.24, so what will got? 43,000 some value is there. Okay, and divided by this one bracket start, this is 2000 into, and this is how much is there? 2 root over of this bracket close. Yeah, so finally we got here to 12.43 something we got. Now this one if I write here, this is 2000 into this is root over of 3, and this one we got here like 12.43 something we got, I hope. Yeah, 12.43. Now this is hm2 to the power 3 by 4. Now we need to find out the value of only hm. Okay, so only hm I can write, this is 12.43 to the power, this will be 4 by 3. So what I got here, let me write to the power, bracket start, 4 divided by 3, bracket close, 28.8. So here I can find out 28.8. So finally hm equal to 28.8 this much meter, correct. This is the manometric height for the second one, hm2. Okay, now what is our requirement? Find out the number of stages. So the number of stages, which is required is equal to the total head or total height, we can say the total head or total height with respect to the head per stage. So actually here it is given the head per stage, actually the height to a height of this one is given, but this is for this stage, for the multi-stage pump. So the total head is given, this is suppose 200 meter, and divided by each stage, this is one stage, because if you see multi-stage means like number of pumps are there in that. Okay, so how many stages are required in this? So if you divide this 28.8 means it will be near about 6 7 30 into 7 to 10, so near about 7 will get. 28.8 is there, that not exactly 30, so we'll get near about 7. So 7 stages are required for this. Okay, and the second one is given, we need to find out the diameter of each impeller. So this is the first one, and the second one I'll write the diameter. So another equation we can consider, that is if you remember, that is hm like 1 root over of hm1 by d1n1 equal to same thing. This is for one, and for the second one also we need to write the same thing. This is hm2 already we have calculated now, and this is d2 n2. Now from here what we need to calculate, we need to find out the, see, d1 value already given to us. So d2 diameter of each impeller, okay, of the similar multi-stage pump, that means diameter of the this multiple multi-stage pump we need to identify. So that is d2. That's why I've written here diameter of each impeller, in the sense that see, a multi-stage pump means how many pumps are used we don't know. If it is, it may be 2 3 4 5 6 7 many pumps are used. So each impeller diameter how much is that we need to find out. So that's why I have written here d2 is the diameter of each impeller. How many impellers are there? Based on that, each impeller the same diameter will be there. So here if you see this equation, the unknown is only d2, remaining values are known to us in this equation. So I'll write only d2 one side, and remaining I'll take it to the other sides, like root over of hm1, that is nothing but 30. So 30 root over into this is n2 is there, n2 equal to 1500. So yeah, no, d2 I need to take it to this side, so hm1 will come here, correct. So yeah, then I need to go for the reverse. Yeah, what I'll do, I'll take it to this one will come down. So root over of hm2 will be in the top, so that is nothing but root over of 28.8 into, and this one n1 will become here, that is 2000 into d1 also will be there with along with that, so that is 0.3, and n2 will be in the denominator. So n2 is nothing but that is 1500, and along with that d2 is there. So d2 taken, along with that we have the this is root over of hm1, so that is nothing but 30. Okay, so this will be cancelled, this is 3 and this will be 4, so this can be also cancelled and you can get 3. So finally we can write, so let's solve it. 28 point, okay, root over of this will do it, root over of this multiply this is 4 again multiply 0.3. Okay, now divide bracket start 3 into 30 root over bracket close 0.3919. So here we got 0.3919, this much meter, and this one I can convert into centimeter or millimeter. So if I want to write into millimeter, then 3000 I can take it. So 391.9, this much millimeter. So this is our diameter of 2 second impeller of the each stage, or impeller of each like diameter of each impeller. Okay, so by this, like what I mean to say, by using these formulas, we can easily find out the parameters which is required for us for the model and the prototypes. Okay, prototype means actual one, and the model one means we need to start the primary one. Now I'll tell you the another some equations which is required for when it is given. Suppose here only two things are given to find out. Okay, now suppose the third case will be given to calculate the power required. Okay, to power required or power developed from that, or what is how much power is required to run this pump, and what will be the power at the prototype, like conditions will be given. So for that case, which formula can be used for this? Now in the last lecture, if you see our previous video, there I have derived this is P by D to the power 5, and this is N to the power 3. So this one we can consider for the one pump or for the model, and that will be equal to the prototype. So either you can write 111, or you can write model, or we can go for the 2 or for the prototype. Okay, this is to the power N to the power, this is 3. Yeah, from this also we can find out each, like which is required for the question. Based on that we can calculate. Even this is for power I talk. Now here what is the things we calculated? Only head we have calculated, and diameter we have calculated from this specific speed equations. Now apart from this is the specific speed equations, and this is the head equation what is there. So suppose another questions will be given in which discharge is related, or discharge is related to that, or acquainted with that question. So in that case, how will you can calculate the discharge value for one pump or second pump which is given. So for that also formula we know, that is Q by dq d to the power q n, and this is for model, and it will be equal for the prototype. So same thing, like dq n here. Either I'll write model, prototype, or I can write this is 1 1 1 and this is 2 2 2. Okay, these two things are the differences in this formula. I hope you understand like how to solve like when the question is given related to models, to find out similarities, similarity between the model and the prototypes. Okay, before going to manufacturing a huge centrifugal pump, in the model itself we can identify the test, we can do the testing, we can identify some things, so we'll go for that. So I hope you understand this lecture. Still, if you're having any kind of doubt and query regarding this, you can give a comment on the comment box. Thank you all.